we're going to look at multiplying 4 different ways. I'm going to show you each of the ways. I have no preference in which way you multiply whole numbers together. You may use whichever method works best for you. I'm going to start with the traditional algorithm, and this is the way that by the time you reach 6th grade, most people know how to multiply numbers. I'm going to set it up vertically like this, and then in the traditional algorithm, it's digit times digit. Okay, so I start with my 3. I'm going to multiply it by 8. 3 times 8 is 24. I carry the 2 up here. I'm going to multiply 3 times 6. I get 18 plus 2, I get 20. And I carry the 2 up here. 3 times 7 is 21 plus 2 is 23. Now when I go to multiply the 4, I don't start here in the ones place, because this is really 40. So we'll put a 0 here to note that this is a 10. And 4 times 8 is 32. Carry 3. 4 times 6, 24. Plus the 3 is 27. Another 2. 4 times 7 is 28. Plus 2 is 30. Okay. This number here, when I do the 4 times 8, the 2 and the 32 should line up right below the 4. If I had another number, I would do another row here. The first number would line up beneath the third. Now that I have my two numbers, I can add them together. And 768 multiplied by 43 is 33,024. The next method I'm going to show you is called the area model. The area model is probably where you first started when learning how to multiply two numbers together of multi-digits. This is where you look at the number of digits in each number, and you're going to set up a grid. I have a 2-digit number and a 3-digit number. So I'm going to set up my grid to be 2 by 3. And then across the 2, I'm going to write 74, but I'm going to write it in expanded form. So 74 is 70 plus 4. And 814 is 800 plus 10 plus 4. Now at each grid block, I multiply the two numbers that intersect there. So here, I'm going to multiply 70 times 800. The nice thing is, just do 7 times 8, 56. Then I have 1, 2, 3 zeros, so followed by 3 zeros. Then you can go to whichever way you want to go. I'm going to stick with the 70, and then I'll do the 4. 70 times 10, well, 7 times 1, 7, followed by 1, 2 zeros. 70 times 4, well, 7 times 4 is 28, followed by 1 0. And then I go to the next row. 4 times 800, 4 times 8, 32, followed by 1, 2 zeros. 4 times 10 I know is 40, and 4 times 4 I know is 16. Then I add all these numbers together. This sum will be the product of 74 times 814. I can add these together. All those zeros plus 6, 6. All those zeros, 8, 12. 8 plus 4 is 12, plus 1 is 13. 1 plus 7 is 8, plus 2 is 10, plus 2 is 12. Carry the 1. 1 plus 6 is 7, plus 3 is 10. Carry the 1. 1 plus 5 is 6. So 74 times 814 is 60,236. That's called the area model. Once again, set up however many digits there are. It's a 2-digit by 3-digit, so I set up a grid that is 2 rows by 3 columns. And then expanded form, then at the intersection is the product of those two numbers. Okay. The next one I'm going to show you is partial products. Partial products is very much like the area model, And it's a lot like the traditional algorithm. With partial products, the multiplication is set up like the traditional model. So 524 times 29. Except now we treat each number as its value. So according to its place value. So this is the number 9 times the number 4, 36. This is 9. This 2 is 20. 9 times 20, 180. 9 times 500. Well, 9 times 5 is 45. Plus is 2 zeros, 4,500. And the same thing. This is not 2, this is 20. 20 times 4 is 80. 20 times 40. 2 times 2 is 4. And then there'd be 2 zeros, so that'd be 400. And this is 20 times 500. So 1, 2, 3. That's 10 followed by 3 zeros. Okay. And then we add these all up. 8 and 8 is 16, plus 3 is 19, carry the 1. 2, 7, plus 4 is 11, carry the 1. Okay, so 15,196. That's the partial products. So these are the three most common ways to multiply: the area model, partial products, and the traditional algorithm. Okay, I'm going to show you lattice multiplication in a separate video, but I just want you to know that it is a third or fourth way to multiply. And when we do it, I have no preference, again, on which way you do it. Lattice multiplication is a little bit like this, but there's a little bit more of a setup for it.